It's time now to move on to the third presentation. And this presentation will be on the results of the INVALSI standardized assessment as a tool for professional development of mathematics teachers.
Okay, good morning everyone. I'm Maria Clara Ciprian. I'm a first year PhD student at the University of Ferrara, and today I want to show you some results from my research, from the research I'm conducting with my colleagues, Marco Saccoletto from the University of Eastern Piedmont, Carlotto Soldano from the University of Turin, and Camilla Spagnolo from the University of Ferrara. Our research is entitled Results of INVALSI Standardized Assessment as a Tool for Professional Development of Mathematics Teachers. And it is part of a broader project entitled Mathematics Standardized Assessment as a Tool for Teachers' Professional Development, which involves several researchers from different Italian universities, and whose main purpose is to develop a model for teachers' professional development consisting of theoretical and operational tools, starting from the results collected from the Italian standardized assessment tests, INVALSI. The INVALSI can be used as an effective interpretive tool of some aspects of mathematics teaching and learning processes specific to the Italian context. And the innovation of our project consists of its bottom-up approach, in which the theoretical framework, test and results from the INVALSI are used immediately as a tool by the teachers to accomplish formative assessment and individualized teaching. So the framework for the design of our model considers three main components, and is the result of the networking of three mathematics education theories. So we assume that the model exploits the characteristics of Jaworski's community of inquiry, so requiring participants to critically examine their practices as they engage in them, question what they do as they do it, and explore new aspects of practice. And that means that in our conception, inquiry is intended as a way of being in which teachers develop a specific attitude that defines the way they act, think, learn, and teach. And we also refer to the mathematics teachers' specialized knowledge model by Perillo Janet, the so-called MTSK model, in which there are two areas of knowledge, mathematical knowledge and pedagogical knowledge, and at the center of the model, as we can see in the figure, there are beliefs on mathematics and on teaching and learning of mathematics. The mathematical knowledge is the one possessed by mathematics teachers in terms of disciplinary knowledge within an educational context, and instead pedagogical content knowledge is the knowledge related to mathematics content in terms of teaching and learning processes. And beliefs about mathematics and its learning and teaching are at the center of the model precisely to emphasize the reciprocity between beliefs and knowledge domains. In particular, the MTSK model allowed us in the preliminary phase of our project, that I will present in the next slides, to frame the teacher's answers to a questionnaire that represented the starting point of our pilot study. Finally, as a third component, we used the meta-didactic transposition model of Attarello and colleagues of 2014. And this construct will make it possible to describe and interpret variables in teacher education processes and to analyze their mutual relation and developments. This model considers the practices and processes that develop during teacher education courses, and in the meta-didactic transposition process, educational practices and theoretical purposes are shared between teachers and trainers. And the term meta-didactics emphasizes that these practices consist of reflection on teaching activities, and within the meta-didactics transposition, practices become meta-didactic practices, as they refer to the action and reflection that characterize teacher education processes, and this could be well developed within a community of inquiry in the sense of Jaworski, as I said before. So, as I mentioned earlier, in the initial phase of our research, we aimed at identifying the training needs of pre- and in-service mathematics, Italian mathematics teachers. And to this purpose, we designed and administered a questionnaire declined in 6 versions, distinct questions with questions that are similar to each other but formulated according to the group of teachers involved and the school level in which they teach or they will teach in the future. In fact, our sample is made up of in-service, Italian in-service and pre-service teachers from primary, lower secondary and upper secondary schools, as we can see from the table. And in the table I also reported the number of our samples. So, for example, we have 39 pre-service teachers from primary school, 22 in-service teachers from primary school, and so on. In the questionnaire, there are questions relating to specific INVALSI item chosen from those available in the existing database and chosen because they are emblematic examples of macro phenomena at national levels. So I mean, for example, multiple choice questions in which the percentage of correct answer by students at national level is very low and whose distractors, so the incorrect answers, can be framed with mathematics education construct known in the literature. And in addition, in the questionnaire, there are also questions that are not strictly related to INVALSI item, but that we defined as transversal, because are specifically aimed at investigating the participant perceived purpose and usefulness respect to the INVALSI test and the impact of them on their teaching practice or their future teaching practice. So to summarize, the focus of investigation of the questionnaire is on the field of mathematical knowledge, the affective sphere, and the beliefs and knowledge of formative and standardized assessment. In particular, the three macro variables on which the questionnaire is constructed are the following. So, mathematical knowledge and mathematics teaching, affective factors, and in particular we refer to Di Martino and Dan's three-dimensional model of attitude, and beliefs and knowledge about the purposes and possible uses of standardized assessment in mathematics about formative assessment. In this presentation, I would like to show you some of the results that we have collected so far from the questionnaire with regard to the interpretation of mistakes, so what we call the analysis of the distractors. And as we will also see in the next slides, we have in fact asked the teacher to reflect on what was the most chosen wrong answers nationally from the sample of all students in Italy, and to give an interpretation of that mistakes in some INVALSI items. So for example, we can see this item, it is the item 6 from the 2012 INVALSI test for students of grade 8. And we proposed this item that asks whether it is possible to calculate the area of the triangle in gray knowing the area of the rectangle. And we proposed this item to our sample of teachers, and we asked them without showing the national response rates, what do you think was the most popular wrong option at national level and why? So we can see from the existing database that the correct answer is C, and is chosen only by 24.1% of the students. And the most chosen distractor is the option B, stating that the area of the triangle could not be calculated because the dimension of the rectangle are not known. And this is chosen by 30.8% of the students, and is followed by the choice of the wrong option A, chosen by the 26.9% of the students. So they say that the area cannot be known because the triangles are not equivalent. And lastly, 16.4% of students choose the wrong option D, stating that the area can be known because the triangle are isosceles. So looking at the characteristic curves of this item, we observe that the curve in I don't know if you can see, but it's light blue, and maybe I can show you this one. This characteristic curve, that is the one corresponding to the distractor B, tell us that this distractor is chosen by students from all the ability level in the test, and with approximately the same probability because it's at the same level for all the logits. And the same applies to the distractor A, that is the line above the first one, so this one, okay? And which is indeed chosen by a percentage not different from that we choose option B. And we can also observe that the characteristics curve corresponding to the correct answer is not particularly in line with the ideal curve. So this one, I can see the color, but this one is the ideal curve, and this one, the last one here, is the characteristic curve of the correct answer. So we can see that there is an underestimation for students with lower ability in the test, in this case, because the real curve is above the ideal curve, and there is an overestimation for students with higher ability in the test. So this is from the existing database, so this is these are the national response rates. So let's see what teachers say to us. With regard to in-service teachers, we can see then that more than half of the respondents identify as the most likely distractor the one that is actually chosen by the national sample. So the option B, because 58.3% choose option B. But there is a good portion of in-service teachers, so 33.3% of them, that states that the most chosen wrong answer might be the option A. And conversely, among pre-service teachers, almost 73% choose option A, so claim that the most chosen distractor is the option A, and only 18% choose option B, and so align with the national student result. And despite this difference between in and pre-service, the reasons given by both groups to explain their choice of distractor are the same, because we can see that the in-service teachers who chose B and the pre-service teachers who chose B say that's because of the absence of numerical data in the formulation of the item, and even who chose A say that it's because probably students feel the triangles visually different. So the reason are the same, and so analyzing the data, we can observe that it seems that maybe in-service teachers are more aware of students' mistakes than pre-service teachers of our sample, and this awareness can be interpreted as evidence of knowledge of features of learning mathematics, that a subdomain of the pedagogical content knowledge of the MTSK model I was talking about before. And this subdomain includes knowing how students might act, their mistakes and difficulties in specific topics, and in general how students interact with mathematics while also considering affective aspects. And in this case, this knowledge seems to be more developed for in-service teachers with regard to the mistake identification, but not for the interpretation of justification, because as we have seen, teachers that choose respectively option A or B identify the same justification for both the distractors. So I have reported another example. This is the item 21 from 2017 INVALSI test of grade 10. So we are in the upper secondary school in this case. The item say consider the line passing through the points A and B. Calculated the slope of this line, and we asked the questionnaire to the teacher the same question as before. So what do you think was the most popular wrong option, and choose a national level, and why? So we can see from the data available on the GStream database that the correct answer is chosen by 29.6% of the students of the national sample. And the percentages of distractor choices are very similar to each other, especially for the two most chosen one, because D is chosen by 24.1% and A is chosen by 23.7%, so quite similar. And this can be also observed from the characteristic curves, because they are like more closer respect the much more closer respect the previous example. And also in this case we have that the ideal curves underestimate students with lower ability and overestimate students with higher ability in the test. So it's quite the same from the previous example. So what teachers say does, we can note that, like the previous example, most in-service teachers do not interpret mistakes in line with national results, so this is a difference. In fact, only 21% of in-service teachers choose option D as the most chosen from the students, and even only 7% choose the option A. And on the other hand, the percentages of pre-service teachers are more equidistributed, like there were the students' answers, even though they do not correspond to the national samples, because we recall that in order the most chosen distractor was option D, followed by A and then B, and in this case the pre-service teachers choose D, then B, and then lastly A. And another thing to note about the respondents, the answers of these teachers is that the motivation given by the pre-service teachers are very varied compared to those of in-service teacher and to those of the previous example. And in fact, we can see that in-service teachers interpret the mistake regardless of the distractors as a problem in the use of the formula in the calculating the slope of the line. And on the other hand, pre-service teachers also mention these problems with formula, but they take into account other factors, for example, the inflation of the data, the incorrectly identifying of the side of the triangle, and so on. So in this case, it seems that pre-service teachers would be more aware of the students' mistakes, and they also give different interpretation, which are not taken into account by the in-service teachers. So we propose you two different examples to show all the aspects that we note from our data. And to conclude, at the moment we are still finishing the analysis phase of the questionnaire. So what I have shown you today is just like a taste of the data we have collected so far. Once they have all been analyzed and interpreted, we want to propose a final version of the questionnaire to be administered to a larger and more varied sample of teachers from all over Italy. And in this way we could conduct a quantitative analysis that will allow us to identify the main training needs emerging from the teachers responding to the questionnaire, and this data will be used to design the first step of the model for teaching professional development that I was mentioned before,